Hello, this is Mrs. Brown, and today we're going to talk about solving quadratics by completing the square. Sometimes factoring isn't enough because especially if your roots are decimals, and we don't want to have to estimate every single time. We've kind of looked at that. And so this is another method that we can use to solve quadratic equations, okay? So the first thing you understand is that you can take x squared plus bx and turn it into a perfect square. That's what we mean by completing the square. In other words, we're going to figure out what the plus c is that makes it a perfect square. So the steps to do that are you're going to start by taking half of b, so half of that coefficient, square the result, and add it to x squared plus bx. So in other words, x squared plus bx plus b divided by 2 squared gives me that perfect square that I'm looking for. Okay, so let's take a look at some examples. All right, so in order to solve this, the first thing I'm going to do is take half of b. So I'm going to do x squared plus 22x plus half of b, which would be 22 divided by 2 squared. Okay, half of 22 is 11. So we're talking x squared plus 22x plus 11 squared. And 11 squared, of course, is 121. So what's c? C is going to be 121. What this means is that if I were going to factor it, it would factor into, this is a perfect square, this is a perfect square, and this is twice their product of the square roots of these. So x plus 11 squared is what this would turn into. But for the purposes of this, we're trying to find c, and c equals 121. But we'll be looking at moving on to this next step in order to solve equations. So again, you take what b is, you divide it by 2 and square it, and that is the third term. That's your c term, and that will give you your perfect square. So let's take a look at this one. So x squared plus 5x plus, I'm going to take b divided by 2 squared. Okay, so 5 divided by 2 is 2.5. So x squared plus 5x plus 2.5 squared. 25 times 25 is 625. So we just have to add the decimal point in. And so c equals 625, 6 and 25 hundredths. And that completes the square. Again, I take whatever b is, divide it by 2, and square it, and I have completed the square. Okay. So let's use this to solve. Basically, here's our steps. We're going to solve the equation, so we're left with x squared plus bx. Right now, I have 3 terms on this side. I want to get rid of the 3. Then I'm going to complete the square, and then we'll solve it by factoring it into the binomial, the perfect square, and then taking the square root. Okay? So I'm going to start by getting rid of the 3. So x squared minus 10x equals 9. Okay? Now I'm going to complete my square. So x squared minus 10x, and that's going to be, plus, negative 10 divided by 2 squared equals 9 plus negative 10 divided by 2 squared, because whatever I do to this side of the equation, I have to do the same thing over here. Negative 10 divided by 2 is 5. Negative 5, and so I actually, negative 5 squared is 25. So I'm going to go ahead and add those. On here, I don't really need to, because, well, the first thing I'm going to do is take the square root of this, because I want to take the square root of this and the square root of this so I can write it as a binomial. So it looks like that. Okay, I could go ahead and change this to 25, take the square root, b is minus, so this has to be minus. I could do it that way. But again, I'm going to be taking the square root of the c term in order to get that number, and the square root of x squared to get that number. Now I have two squares, so all I need to do is take the square root of each side. Okay. That wasn't 36. It's not supposed to be a perfect square. I just realized I did that. Okay. That's 34. All right. So when I take a look at this, this would be x minus 5. Wouldn't it be nice if it was a perfect square? On that side, and then plus or minus. And when you don't have a perfect square on the side, we're going to estimate to about the hundredths place. You'll have some examples in your assignments that will, like real world, it doesn't perfectly come out, and that's totally fine. So when we do that, that's plus or minus about 5.38 when we take the square root of 34, and that makes sense because the square root, 5 squared is 25, 6 squared is 36, so it should be 5 point something, and it should be closer, so that makes sense. Okay, so then when we do this, we now, since it can be positive or negative, to find my final answer, I'm going to do x minus 5 equals negative 5.38, or x minus 5 equals positive 5.38. And so I'm going to solve both of those. Adding 5 to both sides, x equals negative 0.38. And again, adding 5 to both sides, it's going to be positive 10.38. So I started by solving it so that I had x squared plus, or bx form. In this case, it's a minus bx, but it's the same concept. So I moved the 3 over here. I completed the square, so I took half of b, it's negative 10, so half of negative 10 is negative 5. And I added that to both sides, because if I do it to this side of the equation, I have to do it to this side. Once I've done that, I factored this into the perfect binomial, which is x minus 5 squared, and added this incorrectly the first time, fixed it, okay? And then you take the square root of both sides. Remember, the square root can be positive or negative, so we look at those two examples. If the square root of 34 comes out as a negative, or if the square root of the 34 comes out as a positive, and then we can find our two roots. Again, finding these roots would be really difficult by factoring because they're not nice, even numbers. So if we have stuff other than integers, factoring can become very difficult. Okay, so let's look at another example of that. All right, so we're going to start by getting it in the form of x squared plus bx. So I'm going to add 16 to both sides because I need to move it. So I've got x squared plus 6x equals 16. Okay, so now I'm going to take my half b, so that would be 6 divided by 2 squared, and add that to both sides. Okay, well, 6 divided by 2 is 3, and 3 squared is 9. I can leave it here if I wanted to as 3 squared. Over here, I definitely need it as 9 because I need to be able to add that, which is 25, okay? And again, it becomes 3 squared, and 3 times 3 is 9, so that's why I'm adding 9 to that side. Now that I have my completed square, I can factor it by taking the square root of x squared is x, and the square root of 3 squared is 3. I'm adding, okay, from this step. Now that I've factored it correctly, I can take the square root. So I've got x plus 3 is going to be equal to plus or minus 5. I actually have a nice, easy to use numbers this time. So remember, x plus 3 could equal negative 5, or x plus 3 could equal positive 5. I'm going to solve for both situations. When I subtract 3, I get x equals to negative 8. And when I subtract 3 here, I get x equals 2. So my roots, my solutions are negative 8 and 2 for that one. Again, solving it, so you have the form of x squared plus bx, completing the square using b divided by 2 squared. Whatever I do to this side of the equation, I have to do to that side. Once I have completed my square, I'm factoring it. I take the square root of both sides, look at the two possibilities, the positive and the negative, and solve for those. Okay. So sometimes your leading coefficient is not 1. Okay, you have to have a 1 as the leading coefficient in order to complete the square. So to do that, we're just going to fix it, we're going to divide by the leading coefficient each term. Okay, I'm going to start by going ahead and moving the 7 because I know I'm going to have to do that first. You could divide out first, or you could move the 7 first. It doesn't matter what the order is. But basically, I'm left with 2x squared minus 2x equals negative 2. So I'm going to divide out by 2, divide out by 2, divide out by 2 each term. I get x squared minus x equals negative 1. Now I can go ahead and complete my square. Okay, remember if there's no number, it's a 1, so this is negative 1. So x squared minus x plus, and I've got negative 1 divided by 2 squared that I'm going to add to both sides. Okay, 1/2 times 1/2 is 1/4, so negative a half times negative a half is 1/4. I got negative 1 plus 1/4 here. And again, as I look at this side, I'm just going to leave it because it's going to come out to x minus a half. The problem here is I end up with negative 3/4. So my next step is to take the square root. But I can't take the square root of a negative number and get a real solution. So therefore, there is no real solutions to this because this is a negative number and you can't take the square root of a negative number and get a real solution. What this means is that the graph of this particular quadratic doesn't intersect the x-axis, okay? And we talked about that in previous lessons where if it opens up and the vertex is above or it opens down and the vertex is below the x-axis, it's not going to intersect. Okay. All right, so let's look at one last example. As I look at this one, it's already in the form x squared plus bx, except my leading coefficient is not 1, so I have to start by dividing out by my leading coefficient each term. So I'm going to divide by negative 2, I divide by negative 2, I divide by negative 2. That becomes x squared, positive divided by a negative, positive 7. All right, now that I've done that, I can complete the square. X squared minus 5x plus negative 5 divided by 2 squared equals 7 plus negative 5 divided by 2 squared. So as I take a look at this, this is x squared minus 5x plus, and we could make it 2.5 squared equals 2.5 squared, that's 25 times 25 with a decimal, so 7 plus 625. Okay, so I can factor this into x minus 2.5 because it's the square root of this and the square root of this squared, and this would be 13.25. Okay, again, I'm going to take my square roots of both sides now that I've done that. So x minus 2.5 equals plus or minus, and when I type that into a calculator, it's about 3.64, which makes sense because 3 times 3 is going to be 9, and 4 times 4 is going to be 16, so it's going to be somewhere in the middle, 3 point something. All right, and then we look at those two possibilities. Okay, it comes out to the negative 3.64, or it comes out to the positive 3.64. When I add those in, I can end up, I add 2.5 here, I end up with negative 1.14, and my other root is going to be positive 614. Okay. That's completing the square. Again, remember your leading coefficient has to be 1. Just follow those steps. and you'll get it. Okay? I hope this helps and have a fabulous day.